Okay, good afternoon, good evening, good morning, anytime you watch this video. I'm here to do this introduction to computer design and drafting, DCE110. We're still on Matlab, intro to Matlab. I want to do this video to see how we can practice some of the programming examples that you need to learn to um, consolidate your knowledge. Now, I believe that we have been able to build enough um, foundation. And so now I'm going to be using all that we have learned so far before I do the other topics that will follow. We're going to do, um, we're going to touch on symbolic computation in MATLAB, using MATLAB. Uh, we're going to talk about we're going to talk about um, we'll talk about transition to Simulink. So all this going to be covered at this time. So, but let me quickly do this very fast. This will be majorly. Let me share my screen. This will be majorly. I'm going to share this. So I'm going to look at this program example very quickly. Now I'm going to launch MATLAB. I'm going to launch MATLAB. Okay. That is 2014 version because of the similarities to what we have. I actually have two versions on this machine. I have 2018, which is a bit recent, and that's I can use it for recent work, being that I'm using MATLAB for my work. Now, 2014 will be okay because of the size for most learners. Okay, so I'm going to quickly do this to make sure that we understand the way MATLAB can be used to solve problems. Okay, the example we have here, we are looking at programming examples. Vertical motion under gravity. An object is thrown vertically upward with an initial speed v under the relation of gravity g, neglecting air resistance. Determine and plot the height of the object as a function of time from time 0 when the object is thrown until it returns to the ground. Okay, so using all these formulas, the height of the object at time t, h of t is equal to vt minus 1 over gt squared. So this is normally the distance formula from our physics using the initial speed, and then the time, and then the acceleration due to gravity, the time. And the object, so the distance, that's the height of the object, will be this. Then the object will return to the ground at time tg. So this will be it should be equivalent to this. If the initial velocity is 60 meters per second, then we can use this following script to compute it and plot the vertical height as a function of the time of flight. So this is the script we're going to use, and I want you to really understand the script as I try to explain for you to see the power of MATLAB also. Okay, let me quickly look at what we are doing. I need to bring back my command. My workspace is still there. I hope it is there. Yes. Yeah, this is what I was trying to reset yesterday, but I had some challenge. I want this to waste my time. Let me refresh. Okay, there's a problem now. So I need to stop sharing. Okay, let me share Matlab. Okay. Now, okay. There is a way I need to do automatic reset. I have forgotten how that can be done. Let me just continue. I just want to look at my command, and then I'll also look at, let me pick a new script here. Okay, so I believe you are seeing the Matlab. Let me stop sharing so that I want to be sure that you are seeing the Matlab screen. Because I discovered that the other screen, I will think I'm sharing, but I'm not. You will not be seeing the Matlab screen. Okay, so I'm just going to copy from that. I'm going to copy from that. I'm going to. Okay, wait. I'm just going to copy that program. I don't want to type. You should take the time to type so that you can learn the basic of typing code. I just want to explain how the program works so that you can have a better understanding with these programming examples that we have. And you're going to be given some assignments which you need to go through and work on as in group level, in your learning groups, and submit. So, but when you submit the assignments, you will be able to understand more on what I've done. Okay. Okay, let me continue where I stopped. Okay, I want to continue with this. So let me just quickly, let me just type, let me close this. Let me do a new script. Okay, a new script. Okay, I'll just type that program. I'll just type that program quickly. I have this program here, which I want to. Okay, so I want to type. Okay, I want to type the program so that you can be carried along. Okay, I'm going to type it in this editor. Hope you are seeing my editor. So it's going to be, this is a comment, vertical motion on the graffiti. So that's the comment on this program. Then I'll leave another space, percentage comment also. So we have to define the input, define input values. Okay. Now the first one is G, which is the acceleration due to gravity, 9.8. Semicolon is to prevent it from being sent to the screen. V is equal to, you can leave space if you like, 60 according to that question. Semicolon to suppress it. Now, commenting is very important. You just use tab and comment. This is acceleration into gravity of gravity. The unit is normally meter per square minute per second square. This also, I can comment on it using tab to move to that place. Then we have this is the initial speed, so that anyone reading this program can know what it stands for, and this is meter per second. Okay. Now I can leave the space. Percentage for another comment, calculate times. Calculate the times. So with this, that will be T underscore G will be equal to the formula 2 times V divided by G. That's the formula for the time to return to ground. Okay, let me put the comment here. That is time in seconds to return to ground. And now this time will need to be, this time will be generated with the element time factor x will be generated with this. T is equal to okay, let's start with this space. Linear space, starting from 0, comma T underscore G. This is the interval. Then looking for 256. So this will generate 256 element time vector x, in seconds, with interval from the T underscore G calculated from 2 times V over G. So if you try to calculate that, you will see that. Now, let me try to suppress this, but I'm going to remove the output suppression so that you can actually see what that is doing in the code. Okay, let me. It's good to arrange your comments after the code to align for clear reading of the code. Okay, so that it doesn't block the view of the code, doesn't overlap with the codes. Now, this T is equal to list space. It's going to generate a linear value. It's going to be an array vector that will start from 0, incrementing with the value gotten from T underscore G, that is T to ground, which is 2 times V over G. Now, the comment here, it will be 256 element kind vector in seconds. Okay. Now, the next thing is calculating the values for height. Okay, the following code will calculate the value in the space so that there will be quick calculate values for height of T, and then now H is now going to be, so H is equal to V times T minus G over 2, half times G. T is limiting as G over 2 times T. Okay, now you can see this is an array exponentiation. Okay, T dot is going to be performing the operation on each of the value in the array T. Okay, and then raised to power 2. Okay, so that will give us the value of the height, and it will be in meters. Okay, now you should watch out for anything that has to do with red underline or whatever, so that you can know whether there is an attention. I mean, you need MATLAB is pointing attention to something that you need to correct there. So the next thing is to plot. Okay, so I'm going to, we have this, leave a little space, then we say plot the H of T. Now this code we plot. Now this will plot the time, the height, and then it's going to use this. It's going to use this. It's a single quote. It's going to use this semicolon. I mean this column to do the. Okay. It's going to use that semicolon to do the plotting of the graph. That is the marker it will use. That's the object we use. So, okay, I'll need to close that. Then there's a bracket there. I mean, there's be a comma there. Let me see, this plot should be close to that. Okay. Then for the title, this is the plotting area now. The title area, you put whatever you want to put in apostrophe in a single quote. This will be displayed vertical motion under graffiti. Now, this will be put in quote. Now, whatever you see in this color, what color can we say? Can we call this? I think it's, I don't know which kind of color is it, amber or whatever. So that shows that it's going to send it exactly as it is. It's going to put it the way it is. Whatever is in quote will be sent exactly like that. So, and now put command here, then we have three dots. This three dots shows that the line of code continues in the left line, okay? So, and you see that it will not come to the beginning, it will come to a point where it will be expecting to continue the code. So X label, this is label for the X time in seconds, then quotes. So everything turns to that color, showing that it has taken it to be what will be sent exactly as this as our X label. Our Y label will be the height, okay? Open apostrophe, quote, the height in meter. We close the quote. Then you send the grid. Then you say grid. That grid is a Matlab, function command that will put grid around your plot. The plot is a Matlab command or function tied to X label, Y label. So, and they are to do certain things in the plotting. So as we finish this, we will now want to run the program. Okay. Now let's run the program. Okay, let me save the program first. From here, I'll need to save it. Wait, I save. I need to save. Yes. I need to save this. Yes, let me save it as motion. Graffiti. Okay. It will save it as .m and then it will be saved in the Matlab folder. Okay, this motion gravity. Now I will need to, you click on the editor area and then you want to run. Let me run it. Okay, let me bring out the command window so that you can be seeing what I'm running here. Okay, you can see. Okay, now it says file, motion gravity line 16, column 51. Line 16. Grid. Okay, yes. You can see I made a mistake. I did not close the Y label. Okay. I did not close the Y label. So because of that, it's now seeing grid as to the part of Y label. Okay, can you see? So this is how to find out problems. Okay. Let me stop sharing so that I can be sure that you are seeing my Matlab. Okay. Okay. I want to be sure you are seeing the MATLAB because I don't want it. I don't want you to see it at all. Okay, command window. Now, this is it now. So let me run the motion again. Okay. I've not. Let me bring it down here. It's like I have not. Okay, I've not saved it. I need to save it before it will take that into consideration. Okay. Now, when you see your file having a star at the end, that means that's not been saved. So I've just saved it now. So let me run it again. Okay. So can you see? It is running now. Now, this is it here. Okay. This is the vertical motion under gravity. This is the title. This is the Y label. This is the X label. Now you can see this is what it has been able to. Now let's do a little bit of troubleshooting. Okay. Let me look at the code again. Now want us to see the value of this and the value of that is, and then the value of the t, the time generated by the link space function. So when you see this star, that means you have to save it before you run the code, so that it will not. Okay. Now let me look at the command space. Okay. Let me run it again. Can you see? These are the 256 vector elements. This is the T underscore G value that you use, 12.2.449. You can see this. These are the values that are used in plotting this graph. Okay, this graph. So I just want to be sure that this is properly. See, let me be sure that this is. Let me be sure that you saw it. Okay. Let me be sure that you saw it. Okay. Now. Okay, so let me quickly do the next one before I stop this video. I don't want it to be too long so that you can follow. So this is the figure, the plot just generated. So I can close it, and let me go back to put the semicolon for the suppression of the output. Now, if you suppress the plot with semicolon, it will not display it on the screen. So whatever you want to be displayed on the screen, the result, don't suppress it with semicolon. Okay? Now, let me save this. And so I'm going to start a new code from home, new script. Now, I want to do the next one. This, let me share that. Let me share my screen here. Let me stop this so that I can share a new screen. Okay. Yes. So this is what we have just done. This is the code I've typed in, and we have just run it now, and it has worked. The resulting plot has been shown, and this is the plot command is what has produced the dotted line in the plot. This column. Link space is this function generates a vector of uniformly incremented values, but instead of specifying the increment, the number of values is specified. So this function has the form link space start and number. Okay. So the the increment is computed eternally having the value end minus start, then number minus 1. But here you see start, and so it's going to end at the value of so it's actually starting from 0 is going to end at the value of TG, and it's going to have 256 elements. Okay, that is the number of elements to contain. So that means, you see, the computation here is T underscore G is about 12.449. So it's going to start from 0, and because that's the time it's to return to the ground, and it's going to have 256 elements between 0 to 2 to 12.449. So that's what has happened in that program that I've just run now. Let me call that program again because I need to call that program. Let me open that program. Okay, this is let me stop sharing. Let me share Matlab now. Okay, now you can see this is the program. So the linspace actually start from 0. This is the end. So it's different from the other semicolon. Okay, this is not the interval. Sorry, I made a mistake last time. This is not the interval. The other one is when you are using colon. When you have 0 colon as a particular number and then another number. So the middle number will be the interval. But this one is the number is the end. So it's starting, the ending. So actually, as you have already seen, this value gave us 12.449. So start from 0 and end at 12.449, and then it will have 256 elements. So that is the division of that. So if you if I run this code again, you will see what I'm talking about. Okay. Okay. Okay, let me run this code again. I want to actually make you understand this because I don't want it to be misleading. You can see. So starting from the value that can you see the screen here? This is 12.449, the value of T G, the time to return to ground. Now it now start the vectors. 256 vector from it is from 0 and then until it gets to 12 point, can you see 12.449? So that is, so my explanation the first time was a mistake. Okay, now get it correctly this time around. This is okay. So okay, so this is what we have just done now. Take note of that line, linspace, start, end, number. This is the format. Okay, so it takes these 3 inputs. It's a function that takes this. The first one is the start number. The second number is after the comma is the ending number. Then the last number is the elements of that array, the number it will generate, 256 at this time. And the increment is normally with this value. Now look at another example here. X linspace 0 pi comma 11. So 0 is the starting, pi is the ending. Pi is about 3.1416. Then 11 elements. It's going to give you a main vector element. So this is what happens here. So This is the graph, the plot. Now, I want to look at this briefly before I finish this video. Yes. Okay, so I want to quickly share my screen again, MATLAB screen. Okay, now I'm going to do a new script. Okay. So I'm doing the second, yes, multiple plots of polynomial curve. Now this is just to demonstrate the plot, yes. Yes, this is multiple plots of polynomial curves. That's what we want to do now. Consider plotting the two polynomial function. F1 is equal to s squared minus 3x plus 2, and f2 is equal to 2x squared plus x minus 3. So we want to plot this polynomial function. Now, this is how the MATLAB script would do like. I'm just going to type it in, and then you're going to see how it produces this. Okay. So let me just use this. Let me do a new share. Let me share the MATLAB screen. Okay, the editor. So I'm going to just start with the generate plots. That is the comments of polynomial. Okay. Percentage can be used to also hold a space there. Then x, the value of x has to be defined with this array, with this colon to generate the values. Now you can see when you see the colon, you can see the difference between the linked space, comma, and then the array generated by this x. Using colon. Okay. So this one takes the first number is the starting number. The last number is the ending number. The middle number is the interval. So take note of this. Very, very important. Colon, then 5. And then you can do the semicolon to suppress it, the output. Now take note, the other one is inside a bracket, okay? While this one does not need to be in a bracket. It can be in the open, or it can be in angle bracket, whatever it may be. But this is separated with colon. For instance, if you can test out and see if you put the bracket, see whether it takes it. You can see, okay, it takes it. So, so let me quickly finish typing and let's see how it goes. Now, I want to start bringing in some of the things we have learned before. F. Now, it's saying that it's going to pick the first, when you have this, the first row. Okay, sorry, my keyboard is misbehaving. My keyboard is misbehaving. Okay, sorry about that. Let me clean my. Okay, that's step 1. is equal to x dot s prime dot, you have the correct 2, that is, each element is going to be handled one by one. And then we have minus, there should be a space, minus 3 times x, okay, plus 2, okay, okay. The same thing, f, we have colon, not semicolon, colon, taking the second row, second plot, okay, will be equal to, let me show you, will be first column, second column, okay. You have 2 times x prime. Now dot, that is the array multiplication. I mean array, this is exponentiation. Okay, I'm going to treat each of the element of x with this exponentiation, that is power, what, power to the power of 2 x prime, that is 2, that is x prime minus 3. Now this is, okay, this is what is produced here. This is just what we're doing. This equation here, I mean this function here, this function here. Okay, this is what has been converted to MATLAB statement here. Okay, so this is the plot. This is the function. Sorry, this is the function that has been created here. Now this plot, we now do x of f, okay, and it's now going to, we're going to now use plot function to plot the 2, okay. So this is like f of, the first function. This is f, the second function, okay. So let me go back to MATLAB. Okay, editor. So from here, I'm just going to type the plot x, comma f, comma title, then sorry, I put the what I want to be in the title in the quotes, multiple function plots, multiple function plot. Then I end the quotes. See, changes color, that means that is correct. Then I do comma also. Then the 3 dots shows line continuation, the next line. Okay, and see, do not come back to the first. Then I do X label like we do. This will produce the S label title. X label, you see, it can help you. It's already suggesting string. So anything that is string must be in quotes here. Okay. Comma. Grid. Okay, grid is a MATLAB function that displays the grid line. comma, then legend. This is what will explain what each of these stands for. That will be put to label the plots. So don't forget, what you see in that is a typo. So it's not a closing quote, closing quote. It's open quote, closing quote. So don't forget, if you type closing, it's going to have problem anyway. But I think you shouldn't have that problem if you type properly. So you can see, comma, open, F2, close. Okay, then you close that. Okay, so with this, we can go ahead, save. Normally, when you want to save, you go to your editor, you save. Let me save it with polyplots. Okay, polyplots. Okay, I have one there. Okay, let me say polyfunction. I already saved it before. Polyfunction plot. Okay, now let me run it from the editor. Let me click run. Now I have to bring out the, okay, that's brought it out. Yes, you can see this is the plots it has generated. Very, very interesting. So you can see, you see the F1, see the F2. So you can see it will use different line to plot that. So this is polyfunction plots. So you can see polyfunction plots. Now we need to look at the label. Let me check my label. X label is just X. I didn't put Y label. Okay. So this X, I need to, where is it? What is it displayed? Yes, X. It's just very small. Okay, can you see it here? This is the X. So this is from 0 to 5, okay? And this is the incrementation, and this is the incremental value. You go back to, and see, it's using 0.1 as the interval. So when you look at the figure, you see that it's 0.1, 2, 3.5, then to 1, like before it gets to 5. Now this is the X, and this is the F1, this is the F2. So thank you for your attention. This has, let me show you. You can see this is what we have just done here. And this is what, so the resulting plot is what we've seen. The line color differs, allowing the curves to be distributed from one another. Matlab does that. So this is plot with two polynomial curves. Now, this is just programming examples for you. So you have more other examples for you to do for your assignment. Okay, let me stop this.